is start today's class by talking about the experiment that you guys just finished with a simple pendulum. So we had a pendulum going back and forth, and you guys were taking a look at the period of oscillation of the pendulum in seconds, and if it was affected by any of these three variables. We looked at specifically mass, length, and amplitude. Let's hear from Jared. What do you think? Did your group think that mass affected the period of oscillation of a pendulum? Jared shaking his head saying no. Avas, what did you guys think? Mostly the amplitude. Does mass affect the period? No, it doesn't. So as you put bigger masses on there, it shouldn't affect it. How about length, Elizabeth? Does length affect the period of a pendulum? Length does affect. That should have been very clear in your data. As soon as you make a longer pendulum, it takes longer for it to complete a single oscillation. So length definitely affects the period of oscillation of a pendulum. And how about amplitude? Christina, what did your group get when you guys checked amplitude? I'm sorry? There was no correlation. Grace, do you agree or disagree with the fact that amplitude is not correlated to the period of oscillation of a pendulum? Agree. Amplitude does not affect it. I hope that maybe you're meaning length of os, but let me go ahead and write this up on the board. This is an idea that the Galileo actually worked out in the Duomo in Florence. So the Duomo is the big cathedral. It's a cluster of three buildings. There's a cathedral, there's a bell tower, and then there's a baptistry. The bell tower is where he did other experiments investigating the relationship between mass and the acceleration due to free fall. And this is common in Italy. If you've traveled in Western Europe, you'll see that there's clusterings. The bell tower is, of course, a prominent and tall structure, and it's the bell tower in Pisa that is leaning. So when you say the leaning tower of Pisa, it's not an isolated bell tower that's just leaning off to the side. It's a bell tower, baptistry, and cathedral, three separate buildings that are kind of the common architectural style of the Renaissance period. So he would sit in the cathedral, and if you've been into a Gothic cathedral, you know that they're typically built out of stone with huge vaulted ceilings and stained glass windows in the more beautiful ones. And if you've been to the one in Boston, or there's some in New York City, or if you've been fortunate enough to go to Europe to see these things, you know that the ceilings are literally hundreds of feet tall. And before electrification, if you want to have a service in the cathedral after sunset, you had to have candlelight. Those candles were often suspended by cables from the ceiling onto chandeliers. Altar boys would have long sticks with wicks on the end of them on one side so they could light the candles. And on the other side, they still use these things. I've seen them. They have these like little bell-shaped, like things to snuff out the candles on the chandelier, so you don't have to get a ladder and get up to these things. And Galileo would sit, and he noticed that there was a relationship between the length of the pendulum cable and how long it was taking to wiggle back and forth. I'm not so sure he was really into the service at that time. He might have just been like looking at that and figuring. And so this comes out of these observations that he started to make. And it may seem fairly trivial to you. You might say to yourself, big deal. He figured out how long it takes for something to kind of like wiggle back and forth once. But at the time, there was only one way of keeping the time of day. And what was it?
The sun.
Yeah, the position of the sun. And so, before electrification, ancient people had tracked the sun and the stars with great precision. And so we could figure out, based on the position of the sun and the shadow that the sun was casting and the time of year that it was, within a few minutes, maybe, for the better ones, 5 or 10. And, this was actually done quite a bit in the Middle East. And so there are sundials that are really ancient by Western standards in Syria and present-day Iraq and Egypt and even northern parts of North Africa. So, using a sundial to get within 5 or 10 minutes of the time of day was the only way to do it. Now, we had found a way to keep time to a precise second. If this is a pendulum and it's swinging back and forth like so, and it's making that traditional sound of tick-tock, how long does it take to complete one full cycle if it's going tick-tock, tick-tock? What is the period of oscillation? 2 seconds, because if it takes 1 second to swing all the way over there to the other side and 1 second to swing all the way back, by definition, the period of oscillation is the amount of time that it takes to complete one full cycle before it starts to repeat itself. What I'd like you guys to do is to take a look at this equation for the period of oscillation of a pendulum, and I'd like you to solve for the length of a pendulum that would give us a 2-second period of oscillation. Take it easy, Ryan. So go ahead and work on that. I'm going to give you guys just a couple of minutes to figure that out. What would be your next maneuver after that, Josh, in order to isolate the variable L? Yeah, not take the square root, square both sides. And on the left-hand side, I'm going to get period squared over 4 pi squared is equal to L over G. And lastly, to isolate L, Pat, what will I do? Good, multiply both sides by G. I get period squared times G over 4 pi squared is equal to the length of a pendulum in meters. So I'm going to plug in for the period of oscillation 2 seconds, and for pi, obviously 3.14, and G 9.8. So the period of oscillation of a pendulum would change if it was on a different planet. You should be getting something around 1 meter, maybe just shy of it. 0.99 meters roughly. So about 99 centimeters for the length of what is considered a second's pendulum. How many of you have a grandfather clock in your house somewhere? Or maybe in your grandparents' or aunt or uncle's house? The grandfather clock is driven by exactly that, a second's pendulum. So you have a mass at the bottom of it, and it mechanically moves back and forth, and every time it moves, it's advancing via mechanical linkage, a gear. And so therefore, every half step that it takes 1/60th of a rotation on the second's hand. And it's enclosed in a case, typically. There's usually glass on the front of it so you can see the mechanical action of the pendulum. Over time, though, the energy in the pendulum will dissipate. The good news is that since the amplitude of oscillation does not affect its period, that it will be an accurate timepiece even at the end of the day when the amplitude is very small. The small amplitude does not affect the precision of the instrument in order to keep time. So what do you do to a grandfather clock in order to add energy to it so that you can get more than maybe just a few hours of timekeeping out of it? Obviously, if this were a really nice, nearly frictionless hinge and I were to give it some mechanical energy, over time, due to interaction with the air and friction, it's going to dissipate and it eventually won't be able to keep time. Say that again? You can add heat. You're going to add energy some way, but it's not in the form of thermal energy. Has anybody seen a key sticking out of the side typically? Christina, what do you do to that key? Yeah, you crank it up. And so you guys probably don't have watches anymore where you have to crank up. What you're really doing is compressing a spring. And you're storing energy on this clock with a spring, and that spring slowly over time uncoils and continually adds some of that stored elastic potential energy back into kinetic energy of the oscillator. And so what that allows you to do is to keep the accurate time over much, much longer periods of time. Instead of just 3 or 4 hours with a coiled up spring, you can accurately keep time for 24 to 48 hours. And if you have a servant in your house who can crank that in the morning once a day, that thing is keeping accurate time for weeks and months. Nathaniel? The length is in meters, so we should be getting, sorry, I wrote cm there, but you should be getting about 0.99 roughly meters.